Audio clear இருக்குங்களா? Okay, thank you. Right. Good evening. Today's lesson plan. So last session we started with oceanography, but we were able to finish only the landscape part. So today's lesson plan will deal with segments which frequently occur in your newspapers too. Lesson plan for today. We shall start with the, or should I say we should continue with salinity. We did start with salinity, but we have to continue from here. The last point, if I remember, is, hope I'm not wrong, is that rivers adding a large amount of fresh water. So this was the diagram in your note, I think so. Rivers adding water. We talked about residence time, salt staying in the sea for a very long time, and that is why seawater turns saline. Okay, so we need to continue from there. So factors affecting salinity, then variation of salinity with depth, variation of salinity with latitude, variation of temperature with depth, variation of temperature with latitude, then finally variation of density with depth, variation of density with latitude. Once these three components are over, the static part of oceanography is done. It's the moment in which you get more prelims and your mains questions, like usually. Is it clear? And under movements of ocean water, our primary target will be to finish ocean currents. After ocean currents, associated with this, we have a minor introduction for Ekman transport. Ekman transport. Okay, and then after Ekman transport, you have the discussion on your Walker circulation. And Walker circulation is the foundation for your El Nino, La Nina, and ENSO, or El Nino Southern Oscillation. Is it okay? So you know that these components of these topics frequently occur in your news articles also. So once these topics are done, I'm pretty sure you should be in a position to relate to these topics. Ready? So just give me a go if you're ready. We can start the session. Right, thank you. Moving on. So continuing from the topic we left off, factors affecting salinity. I'll tell you the factors. Okay, then we will see examples also. We'll take examples of Indian Ocean and 2 to 3 other seas which you've seen in map reading. There are totally 5 factors which affect salinity. These are these. Factors affecting salinity. Evaporation, precipitation, river runoff, glacial melting, then glacier formation. Glacier melting, glacier formation. 5 factors are there. Give you 30 seconds. 30 seconds, okay. Simple. After writing these 5 factors, you just need to write whether each factor is going to, only 2 options are there. Will it increase salinity or will it decrease salinity? That's it. 30 seconds. Go. Or maybe I'll give you 60. Or 45. 45 would be better. Make it fast, people. Need not send the message through chat box. Don't spam here. Write in your notebook. $30. 15. 7, 6, 5, 4, 3, 2, 1. Ready? So these are the answers you can compare for yourself. See, first do a very simple. It's a package. When it comes to evaporation, and always remember these things, when water moves across different states, water is going to move it in pure states. Okay, so when you take evaporation, water will leave the system. Okay, liquid water molecule gets converted to gaseous vapor. It's not that sodium chloride will fly, NaCl. No, water will fly. Is it clear? So evaporation, water will leave the system. If water leaves, salt will be pending, salinity will increase. Understood why salinity? Because only pure water will leave. Precipitation, which means it can be rainfall, snowfall, hailstones or sleet, anything. And precipitation is pure form of water. Rainwater or snow water, you're talking about pure water. Mostly pure water, even if the aerosols will be dust. Clear? So precipitation is the opposite of evaporation. You add fresh water, salinity will decrease. Package is done? Like both are same. Okay, let's talk about river runoff. River runoff is river is meeting the sea. That's all. I hope you do not make a mistake here because every candidate makes an error or most of the candidates make an error. I would have finished the topic just previously, you'll make an error. Please understand when river meets the sea, at one instant, large volume of water gets added, less volume of salt gets added. Is it not? So large volume of fresh water gets added, river runoff at one particular point will decrease salinity. If you've written increase, you have not understood the concept properly in the last class. If you have any doubts, read the last paragraph in your notes, the paragraph. Every instant, large volume of fresh water, less amount of salt. Then don't counter argue with me saying that, but you only said. I hate when you use the word you only said. Okay, I know you said that in the previous class when rivers are the reason why salinity increases. Please understand the concept is not just rivers plus time. Time is very, very large. Okay, so fresh water addition or rivers joining there will decrease salinity. Glacial melting. I do not know why, but people have problem here also. Glacier is again mostly fresh water. See, there is no difference, there is no big difference between glacial melting and precipitation. Okay, glacial melting is actually your water in solid state. Solid gets melted to liquid state and liquid state gets added to sea. In precipitation, it is directly liquid state. You get the difference? Direct liquid addition. Glacial melting is solid to liquid. Liquid is getting added. That's all. So again, same result. You add fresh water, salinity will decrease. If glacial melting decreases salinity, reverse case, glacier formation, please don't have the misconception or the wrong idea that when glacier formation happens, salt will leave. No. Glacier formation happens, it will happen mostly in pure state of water. Even if salt is there, water will not accommodate salt in that glacier. Or even if accommodation is there, the percentage will be less. You understood? Glacier formation, just reverse of glacial melting. Pure water will leave the system and become solid state. Reverse condition, which means water leaves the system, salinity will increase. Got the idea? So increase, decrease, 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 increase. That should be the order if you're following this table. Right. Now we are going to step up and then understand how does your salinity and temperature characteristics vary over different conditions. Okay. For glacial melting, can we say ice cubes as an example? Okay, I'll tell you the reason why no. When you do that ice cube experiment, the problem is the volume is very less. When we take the sea, it's more of an open system. Closed system examples will not work for that. That is why. Is it fine? Moving further, we are going to study how does your temperature salinity varies with reference to latitude and depth. Now, this is an interesting part. First is quite easy. I'm just going to understand your latitudinal and temperature variation. Ready? So first is variation of salinity with latitude. Okay. Any query, always remember, no? X-axis and y-axis, any graph. X-axis indicates your salinity, parts per thousand, measured in ppt. You clearly know that. So when you move from left hand side to right hand side, it is going to increase in salinity. Ready? Y-axis indicates your latitude. So you are moving from 0 degrees to 90 degrees. It can be north or south. Yes, there will be subtle variations between northern hemisphere and southern hemisphere, but we are just taking the general idea. Okay. Look at the graph x and y axis, then I will draw. Hope you followed. X-axis, 0. Left-hand side is low salinity. Right-hand side is high salinity. When it comes to latitude, low latitude will actually equator. 90-degree north and south is close to polar region. So low to high. See, note what you're going to do right now is when you start from equator and move towards your polar region, remember your net radiation graph. You try to measure what is the net radiation in a different part. So similar to that, you are trying to depict what could be the salinity. Okay, I will draw the graph. See, when it comes to your low latitudes, okay, your tropical region, salinity will be high. You take your polar region, salinity is slightly less. The reason is very simple. You have high salinity in the tropical region, primarily because there is high amount of evaporation. You know that 365 days of the year, your sun's radiation is heavily concentrated in the tropical region between 23.5 degree north and 23.5 degree south. So that's why it's on the right side, high salinity. Low salinity, it moves left, it's somewhere around here, low salinity. Now, one additional information, this is slightly tricky. Maximum salinity is not found in the equator. Maximum salinity will be found slightly north of equator. You can say approximately, 25 degrees north or around 30 degrees north. That is the range. It's somewhere around your subtropical high pressure belt. Now, why does this happen? It's due to your pressure belts itself. See, even though equator receives high amount of temperature, equator also receives large amount of rainfall. Think about your equatorial climate graph. There is rainfall throughout the year. Because of that simple reason, you take your pressure belt diagram, you superimpose this, you'll understand. Equator, subtropical high pressure belt. Okay, low pressure, high pressure. Cloud formation, adiabatic expansion and cooling. You know this very well right now. Descent, adiabatic compression. Is it not? So due to the presence of clouds, you get the idea. Due to the presence of clouds, there is good amount of precipitation. So once rainfall is there, salinity will decrease. So even if there is a high evaporation, I will reduce salinity by adding some more fresh water. Here, there is no rainfall at all. So once heated, it is heated, that's all. Okay, not adding any water to compensate. Fine. So once you've noted this down, use the word finished. Next graph will be very similar. Just let me know. In southern region, any change? I mean, it should work like this. When it comes to southern hemisphere, the intensity will be less. For example, if you look at this maximum salinity will be slightly less in southern hemisphere. The reason being, southern hemisphere is dominated by water. So water doesn't heat up as much as land, So that is why your salinity will be slightly less because evaporation is slightly controlled. Basically, northern hemisphere is much hotter than southern hemisphere all the time. Fine. So last time, okay, tropical region, keyword is evaporation. Tropical region, high evaporation, so high salinity. Polar region, less evaporation, so slightly lower salinity. Within tropical region, between equator and subtropical high pressure belt, equator has more rainfall. So even if water leaves the system, some more water is getting added. So salinity will decrease. But subtropical high pressure belt, what is heated is heated. It will remain high. Second graph, number 2. Second graph is very similar. Variation of temperature. Look at this. Variation of temperature with latitude. Similar character. Okay, look at the x-axis right now. Temperature measured in degrees Celsius, 0. Same thing for y-axis also. Latitude, 0 to 90 degrees north or south. Okay. You should not be surprised. I'll give you a few seconds to draw the x and y axis. Simply for the word salinity, I will replace with temperature, nothing else. Latitude, 0 to 90. Simple. I don't think you have any doubt here. Temperature is high in the equator. You ask me how na, I will take your head and send it to equator. Is it clear? Don't ask me how. Temperature is high in equator. Okay. Polar region temperature will be less. You got the idea? Don't ask me how again. Now I'll take your head and then send it to Antarctica. Polar region temperature will be less, equator temperature is high. But with the catch, again, one more time. Maximum temperature you'll never get at equator. Maximum temperature, registering maximum temperature, like measurement, registering will be somewhere here, slightly higher. Graph seems similar to salinity. Why exactly? I'll give the reason again. Same reason. Low pressure, 0, 30, high pressure, circle down. Correct? You could be asking, sir, rainfall does not decrease temperature. I do know that rainfall does not decrease temperature. There is a catch. High amount of cumulonimbus clouds formation can reduce temperature because these clouds are very white in color and they are very dense also. So there is a good amount of albedo. Good amount of albedo. Okay, here there is no albedo. So automatically, yes, of course, I do understand. This says there will be re-radiation of heat. I do get it. So your night time, there will be very cool temperature. Fine. But if you look at registered temperature in the morning, very, very high. Because there is no albedo at all. No albedo at all. Basically, so maximum temperatures are not exactly at equator. It's there in subtropical high pressure belt. Okay. The reason being, there is no cloud formation, so high temperature. Same graph, same reason. Sorry, same graph, same cell, different reason. There we saw rainfall, no rainfall. Here it is albedo, no albedo. That's all. So if you get a statement, maximum temperature is at equator, always remember it is not. Because cloud formation is very high in equator. Is it fine? Use the word finished if you're ready. One response. Right, thank you. Now moving on. What is the variation of salinity with depth? See, depth component, pay attention. Every batch, once this discussion starts, later, no sir, like from the start you repeat again. I won't do that this time. You pay attention. I'll draw the x-axis graph and y-axis graph. Okay, first you tell me whether there is any problem with graph. I will tell you what is low latitude, what is high latitude also. You tell me whether there is any problem there. Then I will draw the graph. Okay, because we are going to dive deep inside water. We're not at the surface. Variation of salinity with the depth right now. With depth. X-axis no change. We're measuring salinity. So salinity is in x-axis. Parts per thousand. Increasing left hand side to right hand side. 0. Sorry. Yeah, this is 0 for your x-axis graph. Is it fine? Increasing salinity. Left hand side is low salinity. Right hand side is high salinity. See, your vertical y-axis is this one. You get the meaning? It's not about negative value. It is about depth measured in meters. The topmost number is 0. 0 meaning 0 meters. This is mean sea level. Vertical axis is depth. So this measurement is in meters. So when you dive down into the surface, 100 meters, 200 meters, 1000 meters, 2000 meters, that is the depth. Please be cautious. Okay? Depth measured in meters. Y-axis is different. You need to go down this time. Topper surface of water. If you've understood the graph, use the word proceed. Then I will go. If you understood x and y-axis, graph is simple. If you haven't understood, you'll have a problem. 2 responses? Yes, thank you. See, now we'll understand one commonality in the character of factors which affect salinity. One simple commonality is there. All the 5 factors, evaporation, precipitation, river runoff, your glacial melting, glacial formation, all 5 factors can affect salinity only at the surface level. Think about this. Evaporation, surface. Precipitation, only on the surface level. River runoff, just touching the surface, maybe few meters of depth. Glacial formation and glacial melting, it's not that they go miles down the surface, only very close to the surface. That is one problem with all the 5 factors. They do not have the capacity to affect salinity at greater depths. This understanding will prove essential to really appreciate the graph. Please understand, salinity does not vary the same in both low latitudes and high latitudes. The reason being temperature conditions are different, which you know from climatology. Let me explain this. One batch I finished the entire discussion until density with depth. Then the student asked me a question. My heart was broken. The student asked me, sir, everything is fine. What is low latitude? Tell me what is high latitude. I'll tell now itself. Low latitude means number of that latitude will be less. Tropical region, subtropical region, that is the meaning of low latitude. High latitude means close to polar region, subpolar region. Don't you dare ask me that. Is it clear? Tomorrow I will finish physical geography for you. If you will ask me this down. Low latitude, tropical, subtropical, high latitude, polar, subpolar. Followed? Listen here. This is one bottle or beaker. I take 35 parts per thousand, the 3.5% of salt I properly add. So let's say I'm measuring salinity. A large beaker is there, large beaker. This is the depth component. 0, maybe the beaker is some feet. Okay, maybe a tank. We'll keep it a tank. Beaker is very small, a tank. When I measure salinity, you know how the graph will be. Let me show you. Salinity. This explanation is not there in NCERT, people. They have not given in detail at all. Pay attention. I've mixed properly so that it's 35 parts per thousand. So, if I measure salinity at the surface, it will be 35 parts per thousand. I'm placing it inside a dark room. No 5 factors are disturbing. No evaporation, no precipitation, no glacial melting, no glacial formation, no river runoff, no freshwater addition. I'm placing this tank in a dark room. I measure salinity, 35 ppt. I go few meters below. Measure salinity, 35 ppt. Few meters below. Measure salinity, 35 ppt. Get the understanding? You will get a straight line. If it is a tank in a dark room, no 5 factors are there. Now I will do one thing. I will heat. Visualize this. Sunlight is there. Too much of evaporation. Too much of evaporation, water will leave the system, which means salinity will increase. So from 35 parts per thousand, it increases to 37 parts per thousand. Where will it increase? It will increase only on the surface. 37. You get the idea? So what will happen is, sunlight penetration can actively act only for a few meters. Got it? After a point of time, those who played in the swimming pool and well will understand. You just dive down a few meters, even for a few meters, you'll find considerable difference in temperature. You know, sunlight will start diffusing. So what will happen is, this 35 parts per thousand will get deflected to 37 ppt. Why is it actually moving like this? Because normal 35 parts per thousand is moved towards 37 due to heating of the sun only at the surface. Meaning makes sense. Now I'll do one thing. Polar region. Is it clear? Polar region, usually you have this understanding. Sir, glacial melting is there, which means salinity will reduce to 33 parts per thousand. Half agreed. Salinity will reduce to 33 parts per thousand at the surface. Okay. Reason is not glacial melting. People note down, glacial melting and glacial formation, both of them will balance each other. They have a natural tendency to balance each other. The reason being, what is done in summer is redone in winter. So glacial melting, glacial formation are ruled out. Evaporation is not the factor. Okay, like evaporation is less. So evaporation ruled out. River runoff ruled out. Fifth factor is more important. In your high latitudes, there are humid conditions in certain areas. Once you add precipitation, once there is addition of fresh water, 35 parts per thousand will be pushed towards 33 ppt, but where? Only at the surface, because all the 5 factors can affect only at the surface. Now I have a question for you. Answer properly in the chat box. How did we get precipitation in subpolar region? Answer this question. How did we get precipitation in subpolar region? Precipitation reducing salinity, okay? How did we get that? I've taught you. Snowfall. I want the exact answer. This is the reason why we have precipitation throughout. The melting of ice, how much precipitation? Precipitation should fall from the sky. Appade Kutanana means if I give a punch means. Like Bhavani, one punch. Very good. Temperate cyclones. There you are. People, the answer is subpolar low pressure belt. In 60 degrees, you have a low pressure belt. There is always cloud formation, extratropical cyclones, jet streams meandering. Think about British climate, rainfall throughout the year. Laurentian climate, rainfall throughout the year in your North American continent. So there are reasons why you get precipitation. Subpolar low pressure belt. That is why. I already thought this to you. So these are the reasoning part. Okay. So let me draw it in the proper graph. So your salinity from 35 parts per thousand. Oh, space is less. Hold on. You know it is salinity already. So from 35 parts per thousand, it moves to 37 and 33, depending on latitude. 37 parts per thousand. This is for low latitudes. Low latitudes. From 35 to 33 parts per thousand for high latitudes. High latitudes. So there is a zone actually. You take this one, where there is sudden change in salinity, right? This area. Sudden change in salinity. This is called as halocline. Halocline. Sudden change in salinity. Sudden change in salinity. Reason for 35 to 37. The shift happens. Shift due to high evaporation. High evaporation. Here, shift is due to precipitation. Shift due to precipitation. Subpolar low pressure belt. Okay, just indicate that word L. You will remember. You should remember. Due to precipitation, salts settle in bottom. Then how surface level it reduced? Oh man, I don't know how to answer. I don't understand the question. That is a problem. Due to precipitation, salts settle in bottom. What do you mean salts settle in bottom? Please ask later. It doesn't convey meaning. Salt always settles in bottom in that case. Salt is settling everywhere in the oceans. That is why below a certain depth, everywhere it is 35 parts per thousand. People, I already told you come through audio. A question if you post, it should be very clear. Due to precipitation, salt settle in bottom. Then how surface level it reduced? What do you expect me to answer? How many times I told you? Frame a contextually correct question. Use the word finished if you're done. Climatology over, map reading over, geomorphology over, still framing questions like this. Yes, 2 responses. Thank you. Moving on. This time we're going to look at temperature with depth. Ready? Variation of temperature with depth. Chinna twist. Okay. Chinna twist means small twist. Non-Tamil speakers, chinna means small. Temperature graph. Degrees Celsius. Left hand side low temperature, right hand side high temperature. Y-axis same. 0 mean sea level. Depth measured in meters. I will explain the first part. First part is simple. You will understand. First, I will draw the graph for low latitudes. For low latitudes, I have used maybe a blue color line. Okay, fine. Low latitudes, I will use blue color line. Very simple. Surface temperature will be very high in tropical and subtropical region because high insolation. Is it not? So high surface temperature. You're diving down deeper, sunlight penetration will be less, which means after a certain level of depth, your surface temperature will fall down. So it comes down. After that, temperature falls. Sunlight cannot reach beyond a certain limit. Temperature falls, see what happens? Falls down, reaches 4 degrees Celsius. Is it clear? 30 degrees Celsius, 30 degrees Celsius is, a slightly higher temperature, more than what is required for tropical cyclones. You will reach 30. This is 4 degrees Celsius. Okay. If you ask me why 4 degrees Celsius, I will ask you to refer to your notes, properties of water. Under that anomalous property of water, water reaches maximum density at 4 degrees Celsius. So at 4 degrees Celsius, water will sink down. That is why it is 4. Okay. See, look at this. Surface 30. You sink down, water becomes cold. It's at 4. This is for low latitude. Low latitudes. Here you shouldn't have any problem. High latitude, a beautiful curve will come. See. Use the word finished if you're ready. This one you got it. This should be fine because this is actually having no surprises. We'll see what happens here. And for that, I will just take one more page because I don't want to disturb this. This graph is drawn. Low latitude 30 degrees, 4 degrees. Okay. People look at this. High latitude, subpolar region, polar region. Surface temperature will be close to 0 degrees Celsius. Ice is floating, correct? Close to 0 degrees Celsius, right? You sink down, it will increase 1 degree, 2 degree, 3 degree, finally it will come to 4 degree. So your graph will actually be like this. This is the actual graph because when you sink down, you'll automatically have 0, 1, 2, 3, 4. But we are going to make one change because the change is from 30 degrees Celsius to 4 degrees Celsius. This is a greater change. Correct? The change is only from 0 degrees Celsius to 4 degrees Celsius. So the change is very less change. Okay, so the important keyword is this. From the surface to the bottom, as change in temperature is less, temperature is less for high latitudes, it is approximated as a straight line. Approximated as a straight line. Approximated as a straight line. Not the idea. So we will draw the graph later. Just write down this line alone. Greater change, lesser change. Note down this also. As change in temperature is less. Like I have just only 4 degrees Celsius. This is like 26, 27. I'm going to approximate. So approximation only. Actually, this is the graph. Fine. So when I draw the next graph, you should, or you read one more textbook and maybe they have not explained it. They simply put a straight line. You should understand why they're putting a straight line. They've approximated. That's it. So I'll go to the next page. I think you've taken down the sentence. Single sentence only. Correct? So you take your high latitude graph. This is how it is. We approximated like this. Okay, so this is for high latitudes. Within bracket, I will write approximate curve. So this range between 500 to 1000 meters, where there is sudden change in temperature, is called as thermocline. Thermocline. Sudden change in temperature. Sudden change in temperature. Full stop. Use the word finished if you're ready. Next is the last static topic. 5 factors disturbing salinity. Evaporation, rainfall, glacial formation, glacial melting, and river runoff. We started the class with that. Surprising question. One response. 2. One more, I think we can move. Right, thank you. See, before we draw the graph, this is slightly tricky and the work is left to you. I will explain how to draw the graph. You try it yourself. So first we should understand density of ocean water. See, there are three factors which affect density, but we will study approximation as usual. Three factors are there: pressure, salinity, temperature. So all three together can affect density. It's not only one. All three can affect. But of these three, we will study or we will keep only one factor into account. Is it clear? We'll see how. First, I'm going to neglect pressure. Pressure is neglected. Why exactly? See, the reason is you take water. Okay, you cannot compress water beyond a particular limit. Liquids are incompressible. See, you take this water bottle. Just a second. You fill 1 liter. 1 liter fill pannite, take on piston. Ippadina you think you can compress? You cannot compress water beyond a point of time. See, when I say this, people have this wrong misconception. They will say, sir, but what about submarine design? Once you go deep inside water, pressure is increasing. When you go deep inside water, pressure is increasing because you are putting yourself under large column of water. The pressure component which we are talking about is atmospheric pressure. What I'm stating is, if there is a water body like this, and if atmospheric pressure is high, because of this, this entire water won't become dense. You understood the meaning? It is true that when you dive deep, density will increase because the weight of water over your head will be more. That is different. We are talking about atmospheric pressure. You understood now? I cannot really compress water beyond a point of time. That is why I neglect it. Okay, there will be certain parts of the world. For example, you take a subtropical high pressure belts. So there it is possible, but it's very, very less. We'll understand between salinity and temperature who's the dominant guy. Ready? One fan is there. Sorry. You have controller to control speed. One controller, there are only 4 values. One controller, there are 30 values. You tell me which controller will you choose? Controller 1 or controller 2? Or which controller you will choose? Now you will say for this number 1 because only 4 values are that easy to control. Which controller is more dominant, you tell me? Appa, 2 only, no. Now, some people will come, no sir, I like simple control. 4 values. We will understand this is salinity. Let me explain. See, the range of variation for surface salinity is very limited. It can vary between, think about the values, it can vary between 33, 34, 35, 36, 37. That's all. Salinity has a narrow range. You take temperature, temperature can vary from 0 degrees Celsius to 30 degrees Celsius. So when I have so much of control, every single change in temperature will have a larger impact on density. Salinity cannot have that effect. So does it mean that salinity does not have any effect at all? No. The point is, if you want to talk about density, the first and foremost factor which you consider is temperature, because temperature has a wider range. If you have 2 areas and both the areas have the same temperature, like both of them you have the same controller, then salinity will determine the picture. You got the understanding? I'll write it as a passage in the next slide. Between temperature and salinity, temperature and salinity. Temperature has the dominant influence on density because of higher range 0 to 30 degrees Celsius compared to salinity. 33 to 37 parts per thousand. Most parts of the world. Is it clear? So for approximation, underline the word approximate and keep. For approximation, density is considered to be governed by temperature. For approximation, density is considered to be governed by temperature, but always keep the second point I told you. I haven't written that point, but you should keep it in mind. Both, see, like two regions are there, both have temperature, then salinity is king. Okay, there even if you have one single pond, the pond will make the difference. It doesn't matter both if you have queens. Okay, like AC and normal fan. Wow, super. Understanding. Good one. Take it on, use the word finished. I'll just give you the graph alone. That's the last part before we go to ocean currents. Right, thank you. Here we are. Variation of density with depth. Nearby, variation of temperature with depth. This graph you already know. Just keep this by the side to draw on your own. Temperature graph, 0 meters depth. This was your graph. This is for low latitude. This is for high latitude. Correct? Look at this graph. Instead of temperature, it will be density. Okay, density increases when you move from left hand side to right hand side. This is 0, mean sea level, depth measured in meters. Got it? I want you to draw the graph. I'll give you the input, one simple input. See, with increase in temperature, molecules have a tendency to expand. Individual molecules tend to expand, which means density will decrease. With decrease in temperature, okay, molecules will contract, right? Which means density will increase. Keep this relationship in mind. Try drawing this graph. If you know temperature graph, density graph should be very easy. Try this now. Last topic before we move to ocean currents. I'll hold on for a few seconds only. Okay. Know this? That's all. It's inversely proportional. Very good. The answer is mirror image. That's all. Mirror image. Those who couldn't get it, listen here. Yeah. First, we'll try to draw for low latitude. For low latitude, surface temperature is high. If surface temperature is high, density should be low. Correct? With increase in depth, your temperature is decreasing. If temperature decreases, density will increase. With increase in depth, temperature decreases, density will increase, inversely proportional. Low latitude. Okay, look at high latitude. High latitude, temperature is uniformly less as an approximation, which means density should be uniformly high with approximation, that's all. Uniformly high. This area is called as pycnocline. 500 to 1000 meters. This is called as pycnocline. That's all. Mirror image. Good answer. Now we're going to dive into the movement. So far, it did not move. You were just looking at statically. We saw landforms, the salt content, temperature values, and all that. Okay. Now to dive down. When you have done, use the word finished. Let's move to ocean currents. Okay, good. See, there are three different types and the movements of water. Today we will finish ocean currents, and with ocean currents we have some main topics also. That is Walker circulation, El Nino, La Nina, and also impacts of ocean currents on climate, and at least two aspects of economic development is related. That is why. Of three different types of movement, no one variation. When you use the word wave, you're talking about horizontal motion. When we use the word tide, you're talking about vertical motion. Ocean currents are technically movement due to temperature and salinity variations. Got it? I will write the definition. The first challenge which you will face for ocean currents is visuals. How exactly to imagine that. Further, we'll see a video segment also. Okay, so ocean currents. If by any chance you have a book called as an atlas, keep it by the side. There will be an ocean current map. Search in the index. It will be above page number 100 for sure. These are fast moving streams of water in the oceans. Full stop. They are long, narrow, and retain their temperature and salinity characteristics irrespective of the environment. Full stop. Write it down, then we'll go ahead. Why is the salinity range considered only between 33 and 37? Does that mean salinity is not lower or more than the said range? Not at all. You take the question. You can write it down and just explain the question on salinity range. This salinity range of 33 to 37 is the global average for oceans. You take Atlantic Ocean, Indian, and then Pacific. That's where the range is actually there. But you take salinity, that is not the case. You take Bay of Bengal, salinity goes down to 31, 30 in several parts because River Ganga and River Brahmaputra will add so much of fresh water. You go to Gulf of Mexico, again salinity will be less because Mississippi River Basin is adding so much of fresh water. Go to Mediterranean Sea, salinity will be higher, 38, 39, because Mediterranean Sea, on one side you have Sahara Desert. Only Nile River is actually putting up water. Go to Black Sea, salinity is 18, okay, because Black Sea has large amount of fresh water. So individual seas will have variations. You go to Baltic Sea, there are certain areas where salinity is very low, because Baltic Sea is heavily influenced by glacier formation. Why Baltic Sea specifically? Surrounded by land. The 33-37 is the global average for oceans. So individual seas, the range will be much higher. I think that answers your question. Okay. Provided you know where all the seas are. Okay. I hope you remember that. Now we'll try to understand what exactly or how ocean currents are. See, there is a broad classification of ocean currents, and you should understand what they are before we start with this. Broad classification of ocean currents is not warm current and cold current. You tell that anywhere, people will kill you. Broad classification is surface currents and deep currents. Broad classification or broad division, surface current and deep current. Surface and deep. Surface currents transport only 10% of water, which means naturally what you will think is, which means surface currents are not important. But unfortunately or fortunately, we will study only surface currents. We are not concerned about deep ocean currents. Deep ocean currents is a topic which is reserved for geography optional students. Okay, GS students need not worry. You might be asking, why surface currents? Simple reason. We live on the surface. That is why we are not Atlanteans. If we are part of the Aquaman family, then we will study about deep currents in detail. We are surface dwellers, right? Since we are surface dwellers, surface ocean currents influence your climatic characteristics and atmospheric characteristics. That is why our concentration is only on surface currents. If you look at the definition, the previous slide also, it is more tilted towards surface currents. For example, I have said fast moving. Deep ocean currents are very slow. They will take hundreds of years to move for a water molecule to move from one part of your Antarctic Ocean to Arctic Ocean. Forget deep currents for now. It's not required for your exam. Surface currents we will study in detail. Fine. Now for visuals. Okay. Hold on. If I ask you to imagine a river, you will imagine easily. Mountain is there, river is there. Done. I want you to imagine the same river in water. Look at this. This is a sea or the ocean. Okay. Fast flowing stream of water in water. Meandering also. This one. This is your ocean current. Is it clear? And the depth is maximum up to 200, 300 meters only. Okay, it doesn't go below the Pycnoe line. Above the 500 meters maximum. Now that's all. Surface current, always remember the word. That's what we are studying right now. Now, if you look at the definition, it is stated that they have a certain temperature and salinity character different from the environment. See, example, if this is a high temperature ocean current, example, it can move as far as your polar region. Still, its temperature will be slightly warmer. Everywhere the sea will be cold. Okay, but this ocean current will be able to maintain its surface temperature. Salt content and evaporation on this ocean current will be different from the surrounding seas. That is something about ocean currents. Got the idea? So now we'll see the video. That is just for helping you visualize. Is it clear? Give me a minute. Just find it in YouTube. Some of you might be familiar with this video. Hold on a second. Just get the audio clear. Yeah, I know there's no audio. Hold on. People, are you getting anything?
You, Benny Man, taking on the jellies. Okay, that's sick.
Again, you say there is no audio. This shouldn't be holding us back. It's already maxed. People, I'm here only. I have not vanished. Okay. Fine now?
Oh, my stomach. Oh. Oh, man. Hey, no hurling on the shell, dude, okay? Just waxed it. So, Mr. Turtle. Whoa, dude. Mr. Turtle is my father. Name's Crush. You're riding it, dude.
People, forget it. This is only going to take us a lot of time. Okay. At least look at the video right now. Forget the audio. I'll mute it myself. See, the only expression is to make you visualize. That's all. Is it fine? See, there will be a segment in the video where they clearly show you that the water volume is very high in one funnel and surrounding that particular area will not experience too much of speed at all. Okay. It will come right now. Hold on a second. Just watch this. Wish we had audio bits. I don't want it to disturb our session. So you see a stream of turtles using this particular ocean current, and that is true. That is what it is actually based on. This scene, not an exact scene, of course. This movie talks about an ocean current called East Australian Current. So Nemo would be trying to go towards Melbourne and Sydney. Okay, so that will be the location, and you will see that the East Australian Current takes you to Melbourne and Sydney. Is it clear? So the point which you need to understand is, when you're part of the ocean current, you will experience immense amount of velocity. And in adjoining areas of the ocean current, you'll actually not be having so much velocity at all. So that is the idea. So to help you to visualize, I just needed this tool. So as a marine organism, you need not really put in too much of effort. I think you are able to visualize it. If that segment is fine, then I think our objective is done. Is it clear? So now because the music was very good. Okay, and the dialogues are hilarious. That is why. Is it fine? Now moving further. Now since the visualization part is done, we will look at the broad classification of surface currents. Okay, surface currents are broadly divided. Broadly divided. As warm currents. Now only a warm and cold currents come. Warm currents and cold currents. The reasoning is quite simple. Warm, which means surface temperature is high. Warm ocean currents have the tendency to move from equator to polar region. Reasonable. Equator has high temperature. They will move towards the poles. Cold ocean currents return from the polar region because they have lost all the energy. Recharging, they come back again. See, just like you have the trade winds, westerlies and polar easterlies. Okay, so cold ocean currents return back from the polar region to your equator again. So warm ocean currents, equator to pole, Because you carry high temperature. That's your objective. Equator to pole. Cold ocean currents. Cold ocean currents. Pole to equator. Pole to equator. Is it clear? Pole to equator. Now we will understand a concept called gyre. Okay. And for understanding gyre, we'll be using an ocean current map. So if you have the atlas with you, and of course, if you found the ocean current page by any chance, go to the ocean current map. I will be using one. Don't have the atlas, no issues. We'll be using one for class. Okay. Shall I move on? Use the word finish if you're ready. Warm from equator to polar region, cold from polar region to equator. Remember one sentence very clearly. Okay, this will be useful for the image for the exam. Simple thumb rule. Always remember, similar to your trade wind system, westerlies and polar easterlies, we saw the pressure diagram, isn't it? You should never get confused when you draw your ocean current diagram also. If they ask you which ocean current is there in which ocean. Surface currents are, write this block letters, box it and keep. Surface currents are wind driven. Surface currents are wind driven. Okay. What wind? Permanent wind. Ocean current. Later the doubt will come. Sir, wind is okay, but what wind? Here we are. Ocean currents map. Resolution is poor. I think we'll take the standard one itself. Fine, this is good. Right. See, we will study this map step by step. Okay. 70 to 80% of the ocean currents, or most of the ocean currents, will be part of a circulation system called gyre. Some ocean currents will reside outside the gyre. There are three reasons why they reside outside also. So we will first establish the ocean currents which are part of the gyre. Then we will take step by step. Okay, so first we should understand what is this word gyre. Circulation, that's it. Circulation. Circulation, that's all. Gyre. Okay, circulation of water. So they might ask you questions like these. Prelims question. I'll give you 4 ocean currents. Which of the ocean currents are part of North Atlantic Ocean? Which of the ocean currents are part of South Pacific Ocean? So 1, 2, 3, 4. A, 1 and 2 only. B, 2 and 3 only. C, 3 and 4 only. D, 1, 2, 3 and 4. Simple question. So there are totally 16 currents which you need to understand. I'll possibly finish, 20 also, I have no issues. Is it clear? 16 to 20 currents. Is it clear? North Indian Ocean alone you will study under Indian geography because it is different. I cannot have a general one for that, but others it will work. So we'll finish for North Atlantic, then we'll move to South Atlantic, then your North Pacific, then your South Pacific. 4 different gyres we will see. Ready? So every ocean gyre has 4 components. I'll use the blackboard. I will come back to this where we will apply the principle. Okay? So here we are. An ocean gyre is made of 4 currents which include 1 equatorial current, number 2 warm western current, number 3 northern or southern boundary current, number 4 cold eastern current, cold eastern current. Okay. Equatorial, warm western, cold eastern, but before that a northern or a southern boundary slash northern or southern. Use the word finish if you're ready. Okay. True responses, yes, multiple. Thank you. Thumb rule is this. Surface currents are wind driven. Always remember that. So we will start any ocean current, doubt is there, start from trade wind. I will talk about North Atlantic starting from trade wind. Trade winds, this is the diagram, no? Eastern side to western side. I'll zoom in. Okay. Hold on a second. I just want to verify whether the photograph I'm showing you is reaching you or not. Just a small correction. Because there's no point in showing, I'll be assuming you're able to see. I'll finish the entire thing. Then you will say nothing is visible. So just give me a go. Like, okay, you can see the map, right? You can see, right? The words is clear. North equatorial, it is there. Can you see? Fine. Then I'm happy. Okay. See, trade winds are there. All the equatorial currents, which is actually there, you name it as equatorial current itself. Why equatorial current? Because it is there in the equator, no doubt. So the first current in a gyre will be equatorial current. So you take this black color line right here, it is named as NE, North Equatorial Current. That's all. Is it clear? So North Equatorial Current, have no doubts whether it will be having high surface temperature or low surface temperature. It will be high surface temperature. Correct? So when this ocean current is moved towards the western side, ready? Hits the land mass. After hitting land mass, it diverges north. Is it not? Why does it move north? It is a warm ocean current taking more temperature from equator, moving towards the polar region. And at the same time, one more additional input. If you think about the wind system, surface currents are wind driven, no. Westerlies will be here. Western side to eastern side. That's all. Anyway, you can understand. Pay attention. This ocean current is named based on the location itself. Most of the ocean currents, you can understand the naming system. Never need to memorize it all. Most of the names simplify on the location. For example, this is called as Gulf Stream. Why do we call it as Gulf Stream? Because they haven't shown the exact loop. The ocean current will move inside Gulf of Mexico and then accelerate in speed because this is a very narrow area. This moves with very high velocity. So Gulf Stream coming from Gulf of Mexico. Number 3, equatorial current, warm western current. Number 3 will be North Atlantic drift. Okay, this is the northern boundary current, North Atlantic. North Atlantic drift is primarily an extension current, an extension of Gulf Stream. You get it? So this is also warm. Now, point to be noted, why do we separate it as a single current is, compared to Gulf Stream, this will be having slightly lesser velocity. You understand the reason why? See, it's only about a question of distance. I travel away from equator thousands of kilometers, which means I will definitely lose energy. So Gulf Stream will definitely lose some velocity, some temperature, but still it is warm current, North Atlantic drift. After this, forget about this black color line which goes up. We will see that later. A good percentage of North Atlantic drift, which has lost energy, will return back as cold current. I have lost energy. The name is Canary, C-A-N-A-R-Y. Canary current, we call it as Canary current because you have Canary Islands. You understand the reason why? So that is a circle. Equatorial, warm western, northern boundary, Canary current, eastern cold current. Meaning makes sense. Now, next one. I'll go to South Atlantic. Got it? Same process. Trade wind. Equatorial will be eastern side to western side. Hold on. Fine. So this is your eastern, your western current, western warm current. Why do we call it as Brazil current? Is you have the country Brazil here. So western warm current. Is it fine? After western warm current, like they're given it as South Atlantic. Actually, if you're using your atlas, you'll find a current called as west wind drift. West wind drift is given as Antarctic circumpolar. Fine. So that ocean current will be here. This one. Okay, so South Atlantic is not technically correct. They simply use the word South Atlantic because it is the southern part of Atlantic Ocean. It's usually the west wind drift. You got the idea? So which is given as Antarctic circumpolar. This is a cold current. Is it fine? So this is different from your northern hemisphere where North Atlantic drift was an extension. It was able to have high temperature. Here it's a cold current. Returning back as cold current, it is called as Benguela. I really do not know the reason why it is called as Benguela current. In spite of having access to Google, I've never tried that. Eastern cold current. Able to understand how the naming system works? Fine. Now I will do that for Atlantic Ocean also, North Atlantic and South Atlantic. I will finish the gyre for you. Okay. Once the gyre is over, some ocean currents exist outside the gyre, isn't it? So that we will see after the break. Then we will study Walker circulation. So 2 more gyres, I will do it for you. Once you understood Atlantic Pacific, no surprises. Same story, don't throw bottles at me. It will not hit me also because it's virtual. Trade wind. Equatorial current. It is called as north equatorial because it is in northern hemisphere. Travels as far as Indonesia. Sorry. Travels as far as Indonesia. After traveling to Indonesia, moving from equator to polar region, warm western current, Kuroshio. Don't ask why it is Kuroshio, Japanese name. After traveling for thousands of kilometers, you lose energy. Northern boundary, warm current, North Pacific. Is it clear? This North Pacific current transcends the Pacific Ocean. Then it will reach close to your Canada, North America, North Pacific. See that? Returns back as cold current, eastern cold current, California. Because California is right here. So California, we repeated several times. You understand the reason why, isn't it? Mediterranean climate, so special. Transform plate margin, very dangerous. You have a cold current by the name of California. Silicon Valley, so the place is important geographically under several chapters. Is it fine? Come to your south, same phenomenon, trade winds. South equatorial, southern Pacific Ocean. South equatorial travels as far as Australia. You're in the southern hemisphere. After that only you have eastern Australian current. This was there in Finding Nemo. Eastern part of Australia. So it is called as Eastern Australia. So you look at location of Adelaide, Melbourne and Sydney. It is right here. So Nemo would take the, Nemo and friends would take the East Australian current to reach there. So I go there, then find west wind drift, which is a cold current. After west wind drift, it will reach your western coast of South America, and you find the current called as Peru current or Peruvian current because country Peru is here. Got the idea? So that's a 4 guys. Fine. See, it's not really necessary that you noted all of them down because the names will be there in the atlas. I just wanted to complete the cycle so that you feel comfortable. All the 4 guys, principle is same. Start with trade wind, equatorial, warm western, northern or southern boundary, then cold eastern current. Okay. Shall I proceed further? Give me a response. One. Okay, right. So this is the foundational part. Okay, we just need to look at anomalies. You might have found equatorial countercurrent. You'd see something called as East Greenland current. So these anomalies we need to study. Some currents are outside the gyre. Take a break for 5 minutes. When we come back, after we finish that, immediately we will enter Walker circulation, which is the foundation for El Nino La Nina, El Nino Southern Oscillation. Is it clear? 5 minutes. What are the factors that influence ocean currents? That's a very vague question. When you say factors, if you're talking about factors of movement, everything. I would say rotation of the Earth, revolution of the Earth, temperature of ocean water, salinity of ocean water, permanent winds. You can add everything. 5, 6 factors are there. Repeat one more time. Rotation, revolution, temperature, salinity, wind movement. In some cases, if you take deep ocean currents, we saw yesterday, isn't it? Yesterday, as such, we saw with reference to landforms. Remember, not yesterday, like last Sunday, I think. Seamount, deep ocean currents, even seamounts will affect. 6 to 7 factors will be there. If you want generally for surface currents, temperature and salinity. Those two are the major ones. Okay. Now for the anomalies. What ocean currents exist outside the gyre and why do they exist in the first place? First, we'll start with something which is very consistent. You see one person called as equatorial counter. He's sitting comfortably in the center. This counter current is a result of piling up of water. Okay, so think about these two equatorial currents, north equatorial, south equatorial. See, both the ocean currents do only one objective. They start from the eastern side, then they move towards the western side. Is it not? So when they move towards the western side, both of them are piling up a large volume of water. Visualize yourself standing in Brazil. So if you're standing in Brazil, north equatorial current will transfer so much amount of water. South equatorial current also will transport large volume of water. So if this is the water level, picture this, north equatorial current and south equatorial current. Naturally, your water level will increase because there is consistent transport. Ocean currents operate 365 days of the year. You keep pushing to compensate the increase in water volume. Because if there is increase, it's not that water can stand like that. See, visualize this. Let's say that there is a wall. You take a pail or a bucket of water. Just slash that against your wall. After hitting the wall, even if water diverges to both sides, some water volume will come reverse. Is it not? So even if your ocean currents diverge in both sides, some amount of water will return back. That is called as a countercurrent. And countercurrent's reason is piling up of water on the western side of oceans. Not the reason. Same thing is applicable to Pacific too. Same phenomenon will be there. North equatorial will transport so much of water. South equatorial will transport so much of water. The other side, Indonesia will be there. So you push water, it will hit Indonesia, come back again. Counter equatorial. Okay, it's called equatorial countercurrent. If they ask you this question, in which ocean is equatorial countercurrent developed well? The answer will be Pacific. Why Pacific Ocean? Because Pacific is the largest ocean in the world. So there is very good velocity reached by both north equatorial current and south equatorial current. So more water volume transported will result in more countercurrent. That is the reason. I'll write that as a statement in case you miss it. Okay. Counter equatorial current. Counter equatorial current is a result of piling up of water, on the western side of oceans or the western part of oceans. It is well of all the oceans, of all is more of an overstatement. Of the three oceans, it is best developed in the Pacific. Due to its size. Okay. One more gyre between Australia and Africa. No, Ramesh. It's not that it's not there. We will see that later. Like these are the ones which I will need. Is it clear? Northern part of India, I am not going to teach you because you will need monsoon system to understand northern part of India. Southern Indian Ocean, I will teach you. Okay, that I'll teach you. You have a gyre in both northern and southern Indian Ocean, but northern Indian Ocean is tricky. You need monsoon. That I leave it to Indian geography. This is one person. who's outside the gyre. Second individual. I think you're ready. Second person. Very right. Moving on. Focus on this guy. Your North Atlantic drift. He's a warm ocean current, right? See, thing is, part of the ocean current which has lost energy is returning back. This is called canary current. One more segment of the ocean current which is still having warm energy. Now, whenever I discuss this point, students ask me, how is this possible? See, there will be reduction in energy, reduction in temperature, that's all. Look at this. Gulf Stream has very high energy, more temperature. North Atlantic drift, comparatively less energy. This is called as Norwegian current. Why we call it as Norwegian current? Norway, that's all, close to the coast of Norway. Norwegian current will have comparatively less energy compared to North Atlantic drift. It's that whatever remnant energy is there, I'm trying to push as much as possible. So you travel as far as Norway, westerly push. Got it? So this ocean current will return as East Greenland current. You ask me why East Greenland current? I will take your eyes and place it near Greenland. It's on the eastern side of Greenland, that's all. And understanding the direction is very simple. Polar easterlies. You get the idea? So westerlies push it up and then polar easterlies return. Same will happen for your North Pacific also. See the same diagram. North Pacific. North Pacific current returns as Alaska. So, not returns technically. It moves as Alaska, just like the branching of Norwegian current is there. This is a very small, gyre. It's something which is self-rotating. It doesn't return back, rotating here. Got the idea? So I'll write that in the passage, both of them. A segment of the northern boundary currents, continue to move towards the poles. Full stop. So in the North Pacific becomes Alaska, North Atlantic becomes Norwegian, returns as East Greenland. So that's why they exist outside the gyre, because they are continuing to transport heat. One last third person is there. How many gyres totally? 5. 5 are there. 2 in Atlantic, 2 in Pacific, and 1 in Indian. North Indian, why it is not technically a gyre is the circulation will change between southwest monsoon and northeast monsoon. That's why I say, wait for Indian geography. Okay. The gyre changes, just keeps flipping between monsoon season. I'll read it one more time, then I'm going to the map. A segment of the northern boundary currents continue to move towards the poles. Northern Pacific becomes Alaska. North Atlantic becomes Norwegian. Returns as East Greenland. East Greenland is cold because it has lost energy. Coming back again. There are 2 ocean currents, and these 2 ocean currents are very important, even though we are dealing at this with the last. So pay attention. Certain parts of the earth are extensively cold. Even if there is summer season, even if your Arctic ice sheet is retreating, the temperatures are cold enough to sustain 2 cold currents. I will show you the locations. One location is already there with you. Okay. You were baffled in Baffin Island. Okay, you went and asked Queen Elizabeth. Not Queen Elizabeth. Yeah, Queen Elizabeth. Elizabeth and Elizabeth Islands. Then she said, go and ask my son who lives in a beautiful fort. Son in Hudson Bay. Do you remember all these 3 words? I introduced that because you have a current called as Labrador current. See the location right now. Labrador and Labrador current. This is a cold current. Look at Labrador current. It originates around Queen Elizabeth and Baffin Island, Hudson Bay, this region. Got the idea? So here there is no connection with the gyre. Since it is consistently cold, the energy is retracing back. Look at one more current in Pacific Ocean. Labrador is one. Sorry. You take this one. This is Oyashio. So this comes from your Bering Sea. Bear in Bering Sea, you find the difference between Alaska and Siberia. Oyashio. Oyaashio. The current in Atlantic was Labrador. Labrador. They exist outside the gyre. Outside the gyre. These are cold currents. Cold currents, very important for economic development factor of Japan and northeastern United States. Okay. That's the last part. Fine. Now we will spend time on understanding your Walker circulation. Before Walker circulation, a small topic called Ekman spiral. Simple topic. Is it okay? If you know Coriolis force, or not understanding Coriolis force, if you simply know Coriolis force, we'll just apply it over Ekman spiral. Ready? Here we are. Ekman spiral. Can anyone tell me the meaning of Ekman? Anyone knows the meaning of Ekman? Ekman spiral. Meaning, Ekman. Meaning only asked. Does Alaska current merge with any current in the equatorial region? No. Alaska is a self-gyre in itself. Ekman people. Ekman. No response. Ekman. Oak man. No. One man. Adi Hindi. People simply only asked. Ekman spiral doesn't have any meaning. Ekman is the name of a person, that's all. Is it okay? Ekman is the Swedish mathematician. That is it. The Swedish mathematician gave the concept called as Ekman spiral or Ekman transport. So Ekman doesn't have any meaning. If someone asks you, don't tell anything. It doesn't have any meaning at all. Okay, I'll tell you what was the understanding and what he gave the theory. They presented this problem to this particular Norwegian mathematician. The problem was this. There is an observation in Norwegian Sea. What they are seeing is wind direction is like this. Wind direction. This is the wind direction. Most of the sailors understood that if you look at the glaciers were moving like this. Glaciers are there. Glaciers are moving in this direction. They presented this problem, sir. If wind is like this, then glaciers should move like this. Glaciers are moving like this. Please explain. Mathematician, no. Started theory, numbers. So after analyzing, he gave one theory. He said, for a wind direction, water up to a depth of 100 meters. 100 meters will get deflected to the right side by 90 degrees in the northern hemisphere and left side by 90 degrees in the southern hemisphere. It is due to relationship between Coriolis force and the friction. Details are not required. Just understand. This is enough. The basic idea if you got, it's enough. I will draw one more diagram in the next page. This is just theory. He says, sir, this is true, sir. It's because Earth is rotating. So naturally you won't get that. For a wind direction, water up to a depth of 100 meters will get deflected to the right side, northern hemisphere, Coriolis force, left side, southern hemisphere, Coriolis force. It is due to the relationship between Coriolis force and friction between different layers of water. This is what he said. We'll draw the final diagram. Last of all, I'll draw the final diagram here itself. Why wait for the next page? That's only for observation purposes, right? Like this is the truth. He says, sir, if this is a wind direction, blue color line is wind, water up to a depth of 100 meters will get deflected towards the right side in northern hemisphere angle is 90 degrees. Now we understood, moving towards the right side. Right side up to a depth of 100 meters. Again, just for understanding, 90 degrees theoretical. Nowhere in the world you will get 90 degrees. The observed values are between 45 to 60 degrees. Okay, like their observation is that. 90 mathematician, no mathematician will never write something which is there in reality. They will say assume. How many mathematical problems you solved in college? Never comes into reality. Moving on. Walker circulation. People, this is the most important part for oceanography because now we are going to mix two things. Half cup ocean, half cup climatology, stirring, and then we are going to drink. Okay. All your climatology concepts should be on fire. Brain should fire all your neurons. Is it okay? This is a new circulation system which you have not seen so far. It's a cell. I will write the definition, then you'll see the diagram. Walker circulation. Walker circulation. It is a circulating cell present in the southern hemisphere formed as a result of difference in sea surface temperature of tropical waters. Difference in sea surface temperature of tropical waters. Full stop. People, if you've understood this, El Nino is nothing. Very simple concept. This is the crucial one. But people will write only about El Nino. Use the word finish if you're ready. I want your full attention. Half cup climatology, half cup oceanography. We will start from Pacific Ocean. Pacific Ocean will be the most important place for this because El Nino is associated with what happens in the Pacific Ocean. South America, Australia, Equator, Tropic of Capricorn. I start from the ocean currents. Pay attention. People listen, then you can draw. Listen first. Trade wind is the keyword always when you want to draw the ocean current diagram. Trade wind, moving from eastern side to western side, equatorial current. South equatorial, below equator. Similar to south equatorial, here you'll have north equatorial. This is above equator. Just for reference. We are more concerned about southern Pacific Ocean because this is where Walker circulation is dominant. After hitting Australia, western warm current. Name is East Australian current. Then westerlies will be dominant. Westerlies move in this direction. That is why we have an ocean current called as west wind drift. West wind drift because westerlies, western side, eastern side. Returning back as cold current, Peruvian current. Eastern cold current. Now you draw the diagram. Realize and draw what you're drawing. Start from equatorial, come back East Australian, west wind drift, then cover as Peru. Now draw the diagram. Like you should understand what you're drawing. Start with trade wind, then draw. Draw it now. See, you should be in a position to explain El Nino to anyone. That is how you learn. Okay. Trade wind, south equatorial, east Australian, west wind drift, Peruvian. trade wind, south equatorial, east Australian, west wind drift, Peruvian. I've taught you. I want you to draw right now. Use the word finished if you're done. Two responses. Think you are done. Right, good. People, penguins are wonderful birds. They are really funny to watch. Okay, if any point of time you feel bad, watch penguins, you will feel fine. You know where penguins live? Good number of penguins live in Antarctica. Some penguins will live at the peripheral region of Antarctica, very close to Chile, very close to Argentina. Some penguins are there. Penguins are also there in equator. Do you know? Whenever I say this, people laugh at me. Penguins are there in equator. They will say, sir, penguins are animals. Sorry, penguins are birds which survive in cold environmental conditions. How do they form in equator? Penguins are actually there in equator. I will show. See, why you should understand this point is, simply if you learn Peruvian current, tomorrow itself you will forget. Know this fact. Beautiful. Okay. Penguins in the equator. I think you remember where Galapagos Islands are. This will serve as a very good reminder. In map reading class, long back, so long ago that you might have forgotten, I introduced a person called Charles Darwin. Charles Darwin went to Galapagos Islands for his research on origin of species. Okay. Now let's take this region. Okay. This is your Galapagos penguin. Not the idea. Galapagos penguin lives in Galapagos Islands, which is actually there in Ecuador. Remember Ecuador from map reading? Dor in Ecuador, Pepper in Peru and all that. Look at this line. This is equator. And the penguins live on equator. This is the only penguin which is actually found slightly north of equator. You understood? How was it possible? Because of the strength of Peruvian cold current. You get it? This cold current is there. See, this is why you need to understand the power of ocean currents. If this cold current is not very powerful, there is no chance penguins will survive. But cold currents are so good, at least for a small area, the cold currents can maintain a good or reduce surface temperatures. That is why penguins can survive off the coast of Ecuador. So never ever forget that cold current is present here. That is why penguins are there. If still this is difficult to understand, I'll tell you one more thing. You know Kailasa? Swamiji. Kailasa is here only. Cool place. Swamiji knows geography. Swamiji has not simply picked up a random island. Okay, Guruji is so knowledgeable that Guruji has actually chosen this place. Okay. Now, we are going to compare your eastern part of your tropical waters of your Pacific Ocean with the western part. Hope you're ready for this. Same diagram with a twist. Half cup oceanography, half cup climatology. Listen, people. Peruvian current is here. So now we have understood, at least in this isolated section, the surface water is cold. Correct? You have two ocean currents, south equatorial, north equatorial. Pay attention. Simple point. One. Equatorial currents are extremely hot, which means every single day, not every single day, every single minute, all the high temperature which is there in the eastern part of oceans is consistently pushed towards the west. Taking heat, transfer towards the west. Taking heat, transfer towards the west. Which means you take the tropical waters which is on the western side, this western side will be very high temperature. Why is it high temperature? Equatorial current due to trade winds move from eastern side to western side, transporting all the heat. Which means surface temperature will be very high on the western side. Due to presence of cold current, surface temperature is very cold on the eastern side. Climatology shall we take? Fundamental principle of climatology, repeated at least 100 times in class. Surface temperature influences air temperature. Correct? Surface temperature is cold, which means air temperature will become cold. Once air becomes cold, air will settle down. Correct? So, high pressure. Surface temperature is warm, air temperature becomes warm, so air will begin to rise up. Low pressure. Air rises in low pressure, travels in equatorial region itself. We are talking about within the equatorial region. Settles near Ecuador, Galapagos Islands, returns back in Pacific Ocean. This is Walker circulation. Beautiful. See, please note, this is not like your Hadley cell, Ferrel cell, and polar cell. You get the idea? Hadley, Ferrel, and polar cell will operate between latitudes. You take your Hadley, Ferrel, polar cell. You know what will happen? Equatorial low, subtropical high to equatorial low, subpolar low to polar high pressure belt. All these latitudes, it's between latitudes. Okay, you take this cell, the cell is within the tropical region, rising in tropical region, settling here itself. You got the idea? So that is how it is different. This is called as a circulation system. Now, let me go to the definition to make things clear. Hold on a second. In case you're copying also, hold on. See the definition right now. It is a circulating cell, low pressure, high pressure, present in the southern hemisphere, formed as a result of difference in sea surface temperature of tropical waters. Okay, so deep difference in sea surface temperature. Why is difference in sea surface temperature? Because of ocean currents. This is your Walker circulation. Is it clear? So it is in the tropical region itself. Use the word finished or understood if you're done. I'll proceed further. I need to add some more points. Nityananda Island. No, man. Kailasa. See, he's very visionary. He didn't keep his name. Okay, he's actually trying to create something which is unique. If he wanted, he could have named the island in his own name. Swamiji didn't do. Why not in northern hemisphere? Good question. I was about to say that. If you're writing also, just just listen to this. That will be enough. It is not there in northern hemisphere because of domination of land mass. The reason is the presence of a large land area called as Eurasia. Okay, so Eurasia completely prevents you from forming circulation cells. If you look at the definition, I would have meant southern hemisphere, isn't it? This cell-like structure is present in Pacific, is present in Indian, is present in Atlantic also. Why did I teach you Pacific Ocean? Because it is required for exam. You will learn Indian Ocean and Indian Geography. Why? It is required for exam. We will not study Atlantic because not required for exam. That's all. Okay. Southern hemisphere is dominated by water. So everywhere you'll find that. Northern hemisphere, due to presence of land, the cell cannot exist. Okay. It's in the southern hemisphere alone. Yes. Because of presence or dominance of water. Northern hemisphere, it is not possible because of presence of land. So 2 responses. Shall I move on? One more doubt will come. I'll clarify that. Yes, 2 responses. See, one more doubt later will come. Now it won't come. Later it will come. Sir, equatorial region, low pressure belt. In low pressure belt, how come high pressure? People listen. You take 100. You take 10. 100 is high. 10 is low. Within 10, 1 is low. 9 is high. Understood or not? Understood the meaning? See, entire area is low pressure belt only. Within the low pressure belt, I can have variable values. Okay, so don't think that high pressure and subtropical high pressure belt, that much amount of pressure won't be there. Equatorial low pressure life, the pressure is only 10. Within 10, I can have 5 and 9, 6 and 9. That is the variation you're talking about. Keep that in mind. Doesn't mean as high pressure as polar high pressure or subtropical high pressure belt. Now we won't learn. 37 days later, 2 days before exam, you will ask me. Morning 2 o'clock, sir, how come high pressure region in equatorial low? I will kill you if you send any email. See, now we'll understand why this is actually beneficial. See, Walker circulation is a normal one which is there in the Pacific Ocean. Low pressure area is there, isn't it? So when the low pressure intensifies, usually during summer season, you will get good rainfall. When we say summer, we are talking about southern hemisphere summer. That is in the months of December, January. Okay, so during summer season, even more heating will be there. That is the connection. So low pressure is there, cloud formation, air will rise up. So if you think about the countries in this region, Australia is present, North of this, Indonesia was present. So Australia, Indonesia will experience good rainfall. Normally, you take this particular region, you will not experience rainfall along this coastal region. You know what country is there? Peru is there. Is it clear? And the east, on the western part of Peru, you find a desert called as Atacama Desert. One of the reasons why it's a desert region. Basically, you usually do not get rainfall because high pressure region, air will settle down, adiabatic compression, not possible. Something which you all know. Now, this is important for the fishing industry of this region. That you need to understand. Only when you appreciate it, you will appreciate why El Nino is a bad phenomenon. For understanding the importance of fishing industry, you will need to link it with Ekman transport concept. Ready? We'll see this one. I am providing inputs on why water circulation is normal and why it is beneficial for the countries of Ecuador, Peru, like even you can leave out Ecuador, Peru and Chile for their fishing industry. It is related to Ekman transport. See, whenever I draw the diagram, people tell I can't understand. Starting itself, I will ask you dimensions and whether you're able to understand what it is before I start naming them. This is land. You are standing here. This is depth of water. Is it clear? This is the western coast of South America. Understood the diagram or not? Land, this is surface water. This is surface water. This is deep water. Deep water, I'll use different color. This is deep water, the blue color line. Diagram, did you understand? Blue color line is deep water, yellow color plain, surface water. You are standing here. Okay, fine. Will that change the amount of rainfall among the equatorial region? Yes, Jawahar, there are minor variations. Minor variations, accepted. Doesn't the same occur between Africa and South America? Yes, of course. Africa and South America. Atlantic Ocean. Water circulation is present in Indian, Atlantic and Pacific. We are studying only for exam perspective. That's why I'm starting with Pacific, I'll end with Pacific. Indian, you learn for Indian geography. Okay. Now, if we ask you what is Ekman transport, you will say Ekman, who's he? People. Ekman transport states that for a particular wind direction, your surface water only up to a depth of 100 meters is getting deflected to the left-hand side in the southern hemisphere. Correct? People listen. Whenever the high pressure cell is present, like this high pressure cell is in this entire region. Okay. Trade winds are very strong. The trade winds settle here. After settling, trade winds push the south equatorial current. They're very, very strong. Okay, when the Peruvian current is cold. Current is cold, air settles down. After settling down, push it towards the western side. See what happens? Normal condition, trade winds are strong. This is trade wind. Okay, I already asked you, you told yes. Only then I'm continuing the diagram. Southern hemisphere, water will move towards left hand side. 90 degrees ideal condition. We'll get 55, 60. Water will move like this. Left hand side. Based on Ekman spiral. I'll write again. This is wind, trade wind. Trade wind. This is surface water. I'll write it. Surface water. Derived from Ekman transport concepts. Left side because it is southern hemisphere. You're standing here. Push the surface water surface water will go. To replace surface water, water from the bottom will rise. Yes or no? You understood? You push away surface water, water from the bottom rises. This water will naturally come up. You push again water will come up. You can ask me what is the importance. See, the importance is you push water up. You are actually bringing in cold, nutrient-rich water. At the surface, even though temperature is very high, okay, you will have very good amount of photosynthesis. When organisms began to multiply, they will exhaust the nutrients in surface water. So you will need to make sure that the cold water recharges the nutrients. So because of a natural process, there is a tendency for cold or nutrient-rich water to move to the surface. This is what keeps the fishing industry dominant, because once you bring more nutrients, your phytoplanktons will grow well. If phytoplanktons grow well, your fishes will grow well. That's what makes Peru and your Chile as important countries in the fishing sector. I'll write this segment. So due to Ekman transport. Due to Ekman transport. there is upwelling. There is upwelling. Upwelling is movement of cold nutrient-rich water. Cold nutrient-rich water. It helps in the growth of phytoplanktons. In the growth of phytoplanktons. And thus the fishing industry. Thus the fishing industry. So when water circulation is normal, everyone is happy. People in Indonesia and Australia are happy. People in Peru and Ecuador are happy. Happy people. Now we will disrupt their happiness. Use the word proceed if you're done. We don't want to disturb, or only if you disturb, your main topic will be over. Nishant, repeat. Okay, problem is I do not know what to repeat. That is why. See, when I repeat, that's the problem now, I guess. I have told it n number of times. I do not know what to repeat. See, wind direction, Ekman transport, I don't think you have any problem. Surface water will get pushed towards left side. Okay, you push. How do I explain this? Oh, man. I'm trying to look for an analogy. There's no point in repeating the same thing again. See, that's what happens in your fluid medium, right? You push water molecules away, then naturally to replace that, water molecules from the bottom will come up. See, it's not that nutrients are intentionally bottom. You push water, then to replace the water, water will rise from the surface. It's convectional system. Water is circulating on its own. So when water moves up, this water will be cold. Please don't ask me why it is cold. It is not illuminated by the sun. So temperature will be less at greater depths. You're talking about 300 or 400 meters. When this water vertically moves up, nutrients from the bottom is naturally brought up. Nutrients on the surface will get exhausted immediately. You're talking about high temperature. Phytoplanktons will exhaust the nutrients. You want to make sure you keep your phytoplanktons. People will ask me later, what is phytoplankton? Let me tell you this right now. I've already introduced this. Don't tell me I didn't say that. I've already told you when we discussed your oil formation. Plankton means any free-floating organism. Phyto means plant, which means if it has good nutrients, sunlight, and carbon dioxide, it can perform photosynthesis and grow really well. Phytoplant, plankton, anything which moves freely, which means it cannot move on its own. Wherever the water current takes it, it will move. So you bring in more nutrients, phytoplanktons grow well. If phytoplanktons grow well, to feed on that, herbivores, fish will be there. Once fish is there, fishing industry is good. It's as simple as that. You still have a doubt, you ask me later. Now for El Nino. How does the surface water move? Oh man. Which means you were absent when I discussed this. That's all I can say. You were not there in this point. That's the only thing I can assume, man. You're asking me how does surface water move? Refer in your notes. That's all. Is it clear? I go in a certain order to make it comfortable for you. I don't know. And the beauty is, I've written the word Ekman transport in the notes. El Nino is a condition when the cold waters of the Peruvian current become abnormally warm. That is all. Abnormally warm. Sargasso Sea is Ekman spiral example or not? No. Sargasso Sea is a part of the Atlantic Ocean gyre. It's a gyre. It's not Ekman spiral. No. Ekman spiral is something which happens at depths of the water. Okay. I didn't teach you that. It's not required. Sargasso Sea, you can say it is an example of gyre, North Atlantic gyre. So it will rotate around Sargasso Sea. I'll repeat one more time. El Nino is a condition when the cold waters of the Peruvian current become abnormally warm. So two things we need to discuss. One is, why does it become abnormally warm? Number two, what are the consequences? Okay. This discussion, don't ask me right now. I will tell you at the end only. This is not important. There is a very simple answer. Consequences are more important. This is where your mains answer comes from. So we'll discuss this first of all. Ready? So assume that it has become warm. So if the Peruvian current becomes warm, what are the consequences? One by one. South America, not good. South America, Australia. Peruvian current is warm right now. Warm Peruvian current. Warm Peruvian current. Okay, it's like a hero becoming a villain right now. Everything will change. Technically, everything will reverse. You are able to create a conducive condition for the strength of trade winds only because at a cold Peruvian current, right? So cold Peruvian current, surface temperature is cold, air temperature will be cold, air will settle down, high pressure. So once it's settled down, the wind velocity is very high. Trade winds are able to push everything away. So once Peruvian current becomes warm, first consequences, I'll write the consequences here, okay? Trade winds become weak. Trade winds become weak. So once they become weak, they will not be in a condition to funnel the energy into northern and southern equatorial current. Only if I'm strong, I'll transport all the energy to southern equatorial, northern equatorial. Now I can't push anymore. Since I can't push towards the western side, slowly but significantly, all the heat begins to stay in the center. All the heat begins to stay in the eastern side itself before going to the western side. So heat begins to stagnate. So trade winds becomes weak. Equatorial currents are unable to transport heat. Unable to transport heat. Resultant consequence. So if it is unable to transport heat, you can understand what will happen. Heat accumulates on the eastern side right now. Heat accumulation on the eastern side. Paying attention. So one leads to other. Surface temperature influences air temperature. If this becomes hotter, low pressure, air will rise, move as far as Australia, settle near Australia. High pressure, wind blows from high pressure to low pressure. Reversal of Walker circulation. Reversal of Walker circulation. This is the big problem. This is the consequence of El Nino. Okay. So if you think about this, nothing dramatic has happened, no? Low pressure, high pressure has become high pressure, low pressure. What is the problem? Use the word finished if you're ready. We will see how it is problematic. For several countries, more than 30 countries have an issue. It's like this, no? In Tamil, they say, for looking at it only, it will be very simple. But I have so much of a potential. The hero will say no. Like that. Impacts of El Nino. One by one. Affects rainfall in Indonesia. Rainfall in Indonesia. Because right now, Indonesia's location is at high pressure, a place where you should be having low pressure, so its rainfall will be affected. Number 2, droughts and bushfire in Australia. Droughts and bushfires in Australia. People, Australia is already a desert. At least in eastern part of Australia, some rainfall will be there because of that water circulation. There, if we press a high pressure, means adiabatic compression. Look at the location. Adiabatic compression. Adiabatic compression, heating. Heating will lead to conditions of bushfires. Natural. Number 3, floods. That is untimely floods in Ecuador and Peru. Ecuador and Peru. Okay, they are more, that is not all parts of Ecuador. It's mostly equatorial climate. Southern part of Ecuador and area joining Peru. Peru is mostly dry land on the western side. They do not know how to handle water. So flash floods there. Next one. Look at our penguins. Very beautiful penguins. Now penguins are in serious trouble. Threats to biodiversity. Biodiversity in tropical waters. In tropical waters. Next, coral bleaching. Coral bleaching. We will study corals tomorrow. Give you the basic input before going to environment. So coral bleaching. More frequency of cyclones. More frequency of cyclones as heat spreads in the tropics. Heat spreads in the tropics. Full stop. Okay. Heat spreads in the tropics. What happened to penguins if they... That's what I told, no. Penguins will get serious issues. There will be decline in population. Can you repeat how the trade winds become weak? See, it's only about surface temperature influencing air temperature. There is no new principle in climatology. That's the only thing you need to understand. When Peruvian current is cold, there is no disturbance for the wind. Okay, which means air will settle in your subtropical high and in regions of high pressure along the western coast of your Peru. Then the wind systems will naturally get moved towards the equator. Now, when you change it to a warm current, air is not going to settle well. If air cannot settle well, you can't get that push. Is it fine? 82050551. It comes down to ocean current. If ocean current temperature changes, the pressure which leads to trade winds changes. If you affect that, it all assume Peruvian current is hot. I don't get that statement. See, we are not assuming Peruvian current is hot. Peruvian current becoming hot is called as El Nino. I've taught you consequences, impacts. Okay, there are still 2 to 3 things you need to know. You need to know what is El Nino, when does El Nino occur, what is La Nina, what is ENSO. Those terminologies are not done. I didn't tell you why the Peruvian current is hot also. If you've taken that, use the word finished. I will tell you why the Peruvian current became hot in the first place. We'll understand that first. So ready for the important reason, why did it become hot? Fine then. The answer is here. Why does it become hot? In Tamil, there is a legend, Vadivel. Vadivel does that. In our film, he puts both the hands inside the pockets, takes empty pocket outside. Nothing will be there. No one knows. I dare you. Okay, you can go to Google, find any research paper. No research paper will give you a convincing answer why exactly El Nino occur. All the textbooks, all the videos on YouTube, you can go to any class, they will teach you this. They will teach you this. They will never teach you why El Nino occurs in the first place. Let me explain. See, please don't think El Nino is a recent phenomenon. El Nino is a nightmare for countries which are there in the Pacific Ocean. They get affected first. Only then India gets affected over the monsoon season. Fine. One of the worst El Ninos in recent recorded history is 1980 to 1983 El Nino. The devastation was very high, especially loss of biodiversity. Is it clear? To solve the problem, 3 major countries tried to invest in research. The countries include Japan, Australia, and United States of America. See, I mention these countries because you know the level of funding which is actually going into weather science, especially for these countries. They have money, they invested in a program. In 1990s, the program was called TOGA. It means Tropical Ocean Global Atmospheric Studies. The study was relaunched in early 2000s. Again, 2000s. TAO, Tropical Atmosphere Oceanic Studies. The study was discontinued in early 2000s. Now, please note, when we say discontinued, it did not mean it was unsuccessful. What they achieved is they were able to pinpoint, not pinpoint technically, they were able to understand the frequency of El Nino better. Okay, the prediction improved. Prediction definitely improved. This is sure. We are expecting better. We need to understand why there is a problem in determining El Nino. El Nino doesn't have a proper frequency of occurrence. You take your NCRT, they would have given that there is a frequency of 5 years. See, certain textbooks will tell you 10 years, certain textbooks will tell you 2 years. Fine. It means if you have a normal year of water circulation, next year can be El Nino. That is when you say occurring in 2 years. When you have a range of 2 to 10 years, how would you determine the maximum factor? You get the idea. It means if there is a normal year, next year can be El Nino. You can have 2 normal years, third year can be El Nino. You can have 5 normal years, sixth year can be El Nino. Some textbooks say will tell you El Nino occurs once in 5 years. See, when something has a range, you cannot determine which is the exact factor. Why exactly does it occur? Even today, we do not know the X factor. We cannot say due to X El Ninos has occurred this year. We don't know that. This is something which is still under research. But what we can say for sure is that thanks to the efforts of these 3 countries, due to these studies, our prediction mechanisms is improved. So if anyone asks you why El Nino, no problem, say you don't know because no one knows, even these countries. Okay. Now I'll move to the next topic. See, don't be angry with me. This is truth. Fine, I'll move further. Second is regarding certain words. El Nino, La Nina. What do you mean by El Nino? What do you mean by La Nina? And next is ENSO. Simple words. Ready for this? El Nino, La Nina. El Nino means male child or boy child, female child or girl child. First, we need to understand why did they name it male child. It is to do with months. It's pretty easy to remember when does El Nino start and when does El Nino intensify. See, back then, people who were living in Peru and Ecuador, you know that the religion, dominant religion there is Christianity after the spread of Europeans, right? So, you know that Jesus Christ is born on December the 25th, or at least it is said that that's the reference point. He is born on December 25th. So it was found that in the late December and in the months of January, people who were living in the coast of Peru experienced high rainfall. Okay, they felt that, okay, if there is going to be high rainfall, then it is God-given rain. Right? So if there is El Nino phenomenon, surface temperature is warmer, air will rise, rainfall will be there. Problem is they did not know about long-term consequences. This also brought them severe problems because your fishing industry gets devastated. So the naming is in consonance with the birth of Jesus Christ. When does your phenomenon occur? The phenomenon occurs in late December to January. And during this time period, since Jesus Christ was born or considered to be born, they use the word El Nino to refer to as male child. Got it? That is why they named it. They did not know. Gender discrimination. Male child, problem for the world. Female child, everything is good. Remember like that. Why? Because you take La Nina. La Nina is an intensified Peruvian current. You have your normal ocean circulation diagram, normal water circulation diagram. Is it not? If your normal water circulation is very normal, okay, just your normal diagram is very good, too good. That is La Nina condition. Is it clear? And even colder, a colder Peruvian current. Colder Peruvian current. It's more of an extra normal condition. Is it clear? So this has negative impacts. Okay. Negative impacts on most parts of the world. which we saw it as 6 points in here, positive impacts. Now for the word ENSO index, right? El Nino Southern Oscillation. We just address that. No wonder El Nino is problematics. Why it happens only in Peruvian current? Same answer. We don't even know why Peruvian current becomes warmer. Why only Peru? I don't know. Will El Nino affect other regions also? That is other countries in water circulation. Yes. See, it affects even United States of America. See, thing is, it's a consequence. You take Ecuador, north of Ecuador, you have Central America. The pressure system changes, definitely your California will get affected. Heat from your tropical waters will slowly move towards California. So there, California is a cold current. So their sea surface temperature will change. So it's not that the heat will get trapped only in one location. It will slowly spread out to other countries. So you take India. India is in the northern hemisphere. But because of change in southern hemisphere, Indian monsoon system is getting affected. Amazon will experience less rainfall because the other side of the water cell, as part of Atlantic Ocean, will descend over the eastern part of Brazil. So sections of the Amazon forest will receive less rainfall. So it's not just one country, several countries. That's why it's a globally studied phenomenon. Okay. La Nina will affect rainfall, then it's good for Peru country. La Nina is normal condition, man. Normal condition is good for Peru. La Nina is good for everyone. Is it clear? Normal, extra normal, very good, like that. Now for this word ENSO. With that, I will close the class and open the session for doubts, okay? Like, I do need to finish impacts of ocean currents on climate and economic development, but I'll take it up tomorrow and close it out because you might have doubts today, that's why. ENSO, El Nino, Southern Oscillation. Understand the words one by one. Southern is to indicate southern hemisphere. Southern hemisphere. Okay. You take the oscillation. Oscillation is a term usually used in climatological studies or meteorological studies whenever there is alternation between high pressure and low pressure systems. Any place you have a high pressure and a low pressure system, you have a circulation set. There you will find this word oscillation. Example, you might have read it in news. Madden-Julian oscillation. I might have read it in news. Pacific decadal oscillation. Oscillation means change between high and low pressure. Southern oscillation, that is change in high and low pressure in the southern hemisphere due to El Nino, causative factor. Due to El Nino. So they will release ENSO index. ENSO index is compiled by taking in several factors. If ENSO index is positive na not positive for us. Positive na it means El Nino is there. Like they will release this every year after determining several parameters, several factors. If if ENSO index is negative, then La Nina is present. Is it clear? So what is ENSO? ENSO means change in high pressure and low pressure system in the southern hemisphere because of El Nino. If ENSO index is compiled due to several factors. They will consider temperature, pressure, wind movement. All the factors is considered and then is compiled. Just like human development index, several factors are taken into account, isn't it? So it will be released by the World Meteorological Organization. If ENSO index is positive, you can expect an El Nino this year. If ENSO index is negative, you can expect a La Nina that year. Is it okay? So I will end the discussion here. Okay, so tomorrow's lesson plan, I'll tell you now itself. I will extend from ocean current impact, so it shouldn't take more than 10 or 15 minutes for that. Secondly, we'll be looking at waves. So under waves, we will look at tsunamis, possibly 30 to 40 minutes. So 15, 20, 40 makes it 1 hour. Tides will take close to 45 or maybe 1 hour. It depends. Tides. Then finally, we will have coral reefs. Coral reefs, 25 to 30 minutes. So it'll be a good 2.5 hours. That's the last part of the class. So tomorrow I will wrap up physical geography. And then you'll have Indian Geography class by Mr. Karthikeyan. So tomorrow is my last session. So if any doubts are there for today's class, I will save the PDF and send, no problem. Please go for hand raise. I don't want text doubts. I'm not taking textual doubts today. Slides I will send. Okay, so I'm not, I want doubts by audio. So please be participative if you want by any chance. The reason being, it'll be much more clear for both you and me. That is why textual doubts don't work for the millionth time. Okay. Others can leave. Take care. See you tomorrow.
Hello, sir. Can you hear me?
Yeah, hello. Go ahead. Yes, yes.
So
Tell me.
this is positive for El Nino, right? For Australia, Indonesia, right?
Which is
negative, negative is La Nino. That is El Nino.
See, El Nino
Positive
is,
for El Nino.
yeah,
Positive for Australia, Indonesia.
See, please understand, don't take the word. See, I'm not able to comprehend the question. Let me explain. If that segment is not clear, please ask me. ENSO is an index like Human Development Index. It's a number, value, that's all. If ENSO index is positive, it is an El Nino condition. If ENSO index is negative, it is a La Nina condition. El Nino is negative for all the countries in the world. La Nina is positive for all the countries in the world. That's all. Is it clear?
So, okay, sir. I understood that thing, but that El Nino, because of the El Nino, only that Australia, Indonesia, they get the rainfall, right? So it is
Because of
good
El
for
Nino,
them.
hold on a second. Because of El Nino, they will get less rainfall. Look at the. There is high pressure. If there is high pressure, you cannot have rainfall. Australia have bushfires. Indonesia will experience droughts. Is it okay? This is El Nino. High pressure, no rain. Fine now.
So Egmont only because of get the Australia. Yeah, I got that. So the Egmont circulation only the Australia things will get rainfall. The Egmont.
It's Walker circulation. Walker.
Yeah, water circulation.
Walker
Yeah,
circulation.
got it. So, sir, you are not told that Peruvian current why it is getting hotter because it is bringing the cold current from Antarctica to here, right? Then you are not told why the Peruvian get warmer.
See, I've clearly told you, man. I told you no one knows the answer. I told you, I spent an entire slide on that. I told you no one knows the answer. If you find the answer, they will give you Nobel Prize, man. They will create a Nobel Prize for geography and then give it to you. Okay, you become a scientist and then find it out for me. No one knows. I spent an entire slide for that. There is no reason. I told you, there is no X factor. We don't know. Japan doesn't know. Australia doesn't know. USA doesn't know. How will I know?
So,
Yeah.
okay.
Good evening, sir.
Hello?
Sir,
Yes, ma'am.
my doubt is regarding pre-storming, sir. Tomorrow we have this geography test regarding how to prepare for geography. Means we have to prepare along with map reading or even for geography test, I must.
Madam, when you prepare for
Because we have separate tests for map reading, sir.
Map reading, map, you forget now, ma'am. Physical geography test, physical geography syllabus, you know, no? Physical geography syllabus you prepare. That test they would have given no syllabus, this is there. Kuduthirpaangala syllabus.
Kuduthirukanga, sir, but sometimes கொஞ்சம் sure ஆ இருந்துக்கணும்ல sir, because climatic regionsலாம் we should know the countries exactly.
ரொம்ப சிம்பிள். நான் ஜியோகிராஃபி டெஸ்ட்னு சொல்லிட்டு ஹிஸ்டரி क्वेश्चन கூட உள்ள கேட்டு வைப்பேன். நீங்க ஏதாவது பண்ண முடியுமா? முடியாது. ஜியோகிராஃபி क्वेश्चनல மேப் இல்லாம क्वेश्चन பேப்பர் எடுக்க முடியாது. மேப் கண்டிப்பா வரும். படிக்க தெரியலனா பரவாயில்ல. பிசிக்கல் ஜியோகிராஃபி மட்டும் படிச்சிட்டு வந்து எழுதுங்க போதும். மேப் டெஸ்ட்டுக்கு மேப் படிச்சுக்கோங்க. டைம் இவ்வளோதான் இருக்கும். எவ்வளோ படிக்க முடியும் படிச்சுட்டு வாங்க. ப்ரியாரிட்டி ஃபிசிக்கல் ஜியோகிராஃபி கொடுங்க. மேப் ரீடிங் 6 கிளாஸ் 7 கிளாஸ் நோட்ஸ் ரிவைஸ் பண்ணும். கஷ்டம், டைம் இருக்காது.
Okay, sir. Thank you, sir.
ஓகே. நான்-தமிழ் ஸ்பீக்கர்ஸ் ஹவு டு லேர்ன் ஃபார் ஜியோகிராஃபி இஸ் a question. கேட்டீங்கன்னு வைங்களேன். Unique doubts are coming. I will simply say, the book is read book. How many classes I have finished with you? How many hours we have spent together? People. Anything else?
Can you hear me, sir?
Hello, ma'am, tell me. How to prepare for exam?
No, not that one. So did you remember that I was talking about the daylight saving part? If you could take 10 minutes tomorrow to explain that would
fine,
be.
I will do that. I'll do that. Fine. I'll close it out tomorrow.
And I still don't see that video which has been uploaded for.
Climate, right?
Right, yeah.
Yeah, ma'am. I've actually told they've informed me that they've uploaded. Maybe it is one of the videos in the set, or maybe the same video was re-uploaded. That is a chance because I've asked them, and they said it is done.
Okay. In that case, I go through that day's video because I don't see any other day's video. Yeah,
Maybe they have
sure.
changed or re-uploaded. That I've confirmed that day because you gave a second input, so I confirmed with them.
Okay. In case if that is not there, if any future classes has been planned for that particular section, can I get an admit into that class, sir?
Ma'am, that the batch might be a weekday batch, so we need to specifically inform you. So you need to keep in touch with the academic coordinator in that case. See, I haven't started equatorial climate for, I don't know, like batch 8, batch 9, batch 10, batch 11. So those are weekday batches. I'm not aware whether you can participate in weekdays in case you're working. Else you can stay in touch with the academic coordinator. If they can inform me, I can tell you which class might have the topic. I have no problem.
Okay. Who's that? Jayshruti ma'am?
Yeah, you can ask her. Correct.
Okay. Thank you so much, sir.
Sure. Fine, and that's the last one. So I'll close the class. So last class tomorrow.
And I'm back, sir. Sorry. I just missed one more. Since the last day of class tomorrow, could you please give us some inputs on how to prepare on prelims?
Tomorrow inputs on what?
Inputs on prelims preparation
Fine.
for
So
27th of June.
Okay, fine. Fine. I'll tell you. See, the only thing is, usually my advice for weekend batch will be different. I'll give you a general advice. I always ask weekend batch students to prepare for 18 months. That would be the right timeline. I'll tell you how to do it because I'm working. I know how difficult it is, but June 27, I'll give you a wrap-up plan. Yeah, that I can tell you tomorrow. I'll do that.
Sure. Thank you.
CROC 2049376. Akhilesh. Okay. Fine then, people. I'll save the PDF and send, and tomorrow we'll close it out. Take care. Bye. See you tomorrow.